3I, Atlas, the interstellar visitor that shook planetary defense. A comet from far beyond our solar system is rushing inward, on a course that takes it alarmingly close to Mars, and, in the eyes of some, even posing a distant risk to Earth. Its name, 3I, Atlas. Discovered on July 1, 2025, this icy wanderer is moving at an astonishing 87 km per second, faster than anything astronomers have ever tracked inside our system. From the moment it was spotted by the Atlas telescope in Chile, questions have poured in. Is it harmless? Could it pose a danger? Or is it something stranger still? Discovery and classification. At first, the object was logged as C-2025N1, Atlas. But its unusual motion, an orbit not bound to the Sun, meant it soon received a rarer designation, 3I, Atlas, marking it as only the third known interstellar visitor after Oumuamua, 2017, and 2I, Borisov, 2019. Unlike those earlier visitors, Atlas revealed its cometary nature immediately. Telescopes across the world detected a glowing coma and a dust tail within days of its discovery. Spectral readings from Hubble and ground-based observatories confirmed it was venting water, carbon dioxide, and carbon monoxide, the classic signature of volatile ices boiling away. Its nucleus is still uncertain in size, possibly as small as 320 meters, or as large as 5.6 kilometers, a body weighing billions of tons. A high-speed intruder. The comet's trajectory is hyperbolic and retrograde, slicing downward at an angle of about 5.5 degrees to the Solar System's orbital plane. Its eccentricity exceeds 1.0, proof it is unbound and destined to leave our Sun behind forever after one pass. Its closest approach to the Sun will occur on October 29, 2025, at a distance of 1.36 astronomical units. But before that, its most intriguing moment will come near Mars. Close call with Mars. Orbital solutions released in September 2025 show 3I, Atlas will pass within 28 to 31 million kilometers of Mars, close by cosmic standards, though still tens of millions of kilometers clear. The flyby is due on October 3, 2025. For Earth, there is no immediate danger. At its nearest, Atlas will remain about 1.88 astronomical units away, over 270 million kilometers from us. But Mars is not entirely out of concern. Several spacecraft currently orbit and explore the planet: NASA's Mars Reconnaissance Orbiter, ESA's Trace Gas Orbiter, China's Tianwen-1, and even Perseverance on the ground. Any shift in trajectory, or fragments ejected by outgassing, could pose a hazard to this billion-dollar fleet. The rumors and the reality. In August 2025, leaked internal memos from Harvard's Center for Astrophysics hinted at a narrowing of the comet's projected path. This sparked waves of speculation online, inflamed further when noted astrophysicist Avi Loeb suggested in a paper that Atlas's regular gas emissions every 17 minutes might resemble controlled propulsion. The nuance, that this was only a hypothesis, was quickly lost. Within days, headlines and YouTube videos claimed the comet was an alien probe steering toward Mars. Yet, NASA, ESA, and multiple observatories remain firm. There is no verified evidence of self-propulsion, no confirmed danger to Mars, and no threat at all to Earth. The repeating outbursts are unusual, but likely natural. Similar effects have been seen in comets within our own system. What could go wrong? If anything, the real risk lies not in planetary destruction, but in spacecraft vulnerability. An impact on Mars is extraordinarily unlikely, but ejecta from the comet, or even dust stirred by its gases, could endanger orbiters. Should a direct impact ever occur, the energy released would be staggering, equivalent to millions of megatons of TNT, easily enough to excavate a crater tens of kilometers across. Fortunately, no current models predict such an event. Still, even a non-impact pass could seed Mars' atmosphere with dust, potentially interfering with solar panels and communications. How scientists are tracking it. To keep track of 3I, Atlas, astronomers have assembled a worldwide network of instruments and techniques, each adding a piece to the puzzle. The first tool is astrometry. This involves carefully measuring the comet's position against background stars, night after night. Each data point is like a breadcrumb marking its path across the heavens. Already, more than 2,700 measurements have been submitted to the Minor Planet Center, from observatories in Chile, Hawaii, Spain, South Africa, and beyond. These numbers may look dry, but every one of them sharpens our picture of the comet's future course. Next comes spectroscopy, the science of analyzing light. When sunlight bounces off the comet or shines through its cloud of gas and dust, it carries fingerprints of the chemicals within. Instruments on Hubble, JWST, and large ground-based telescopes have detected water vapor, carbon dioxide, and carbon monoxide, but also surprising spikes in cyanogen, a compound rarely seen in such abundance. These findings hint at layers of pristine ices being exposed as the comet heats up, and possibly reveal a structure unlike anything we've seen before. Astronomers also rely on photometry, measuring how the comet's brightness changes over time. From these light curves, scientists determined that Atlas spins once every 16 hours. But what caught their attention was something even stranger: a repeating burst of gas and dust, every 17 minutes, almost like clockwork. Most comets eject material chaotically, but Atlas's rhythm suggests something about its internal structure, or some process we don't yet fully understand. Finally, all these observations are fed into Monte Carlo simulations, powerful computer models that run thousands of possible futures for the comet. Each run tweaks the inputs slightly. What if a gas jet nudges it harder than expected? What if a crack opens on its surface? By stacking up these virtual futures, scientists can map out not just the most likely path, but also the extremes. This approach explains why some charts showed narrow outlier paths grazing Mars, even though the main solution keeps it nearly 2 million kilometers away. Together, these methods form a global safety net. JWST, Hubble, the Very Large Telescope, and radar facilities on Earth are all tuned to Atlas, cross-checking each other's results. The collaboration is unprecedented, reflecting just how unusual this visitor really is. What we know, and what we don't, so what has all this effort revealed so far? First and foremost, Earth is safe. No credible trajectory, not even the wildest outlier, brings 3I, ATLAS anywhere near our planet. Second, Mars is almost certainly safe as well. The closest projected approaches still place the comet nearly 2 million kilometers away, a vast distance compared to the size of Mars itself. Even the most extreme computer-generated paths, the so-called 3 sigma outliers, would only skim tens of thousands of kilometers from the planet. That's close in cosmic terms, but still far outside a direct collision zone. Third, the dramatic idea that Atlas is an alien probe remains speculation without evidence. The gas pulses it emits are certainly peculiar, but other comets within our solar system, such as Comet 67P, have shown repeating jets caused by thermal cycles and internal cavities. Atlas may simply be a more extreme version of that same natural process. Still, big questions remain. How large is the nucleus, closer to a few hundred meters or several kilometers across? How much mass does it carry, and what hidden ices might it hold? And perhaps most intriguing, what exactly causes its steady, repeating 17-minute heartbeat? Is it purely geological and thermal, or is there some new physics at play? NASA's Goldstone radar facility is scheduled to scan the comet in early October, just days before its closest pass to Mars. Those results may finally pin down its true size and help explain whether it's stable, fractured, or even on the verge of breaking apart as it nears the Sun. Why 3I ATLAS matters. Even if Atlas sails harmlessly past both Earth and Mars, it still carries a powerful message. In less than a decade, we've discovered not one, not two, but 3 interstellar visitors. Once thought to be once-in-a-lifetime events, they're now appearing within years of each other. That suggests they're more common than we ever imagined. And that realization comes with consequences. Planetary defense has always been focused on protecting Earth from asteroids and comets bound to our own solar system. But Atlas is showing us that the challenge may extend much further. What if the next interstellar object crosses paths not with Earth, but with Mars, where we now have billions of dollars worth of spacecraft? Or what if, one day, one does set its course toward us? 3I Atlas is more than just a curiosity. It's a rehearsal for the future, a test of our ability to coordinate globally, to track the unpredictable, and to prepare for cosmic visitors that don't follow the rules of our familiar solar system. For now, the verdict is reassuring. Earth is in no danger. Mars is very likely in no danger. But as this comet makes its dramatic sweep past Mars in early October and then dives toward the Sun at the end of the month, astronomers will be watching every flicker of light, every burst of gas, every unexpected shift in its course. Because while Atlas may pass us safely by, its message is clear. The universe is full of wanderers. And one day, one of them might not miss.